All right, AP Chem, here's the most missed questions on review number 5. Good job on this review. There weren't very many questions, but I'll go through them here. A couple concepts. The main concept that you want to review, if you're one of the students who's doing this review, is oxidation reduction. And remember, the best way to remember this is oil rig. Oxidation involves loss of electrons, and reduction involves gain of electrons. And so this question, which of the following processes or which of the following represents a process in which a species is reduced? You're looking for a species involving gain of electrons. Well, if you gain electrons, you get more negative. So A, we didn't gain electrons, we lost electrons. This was oxidized. Again, we didn't gain, we lost electrons. That was oxidized. How about this one? We get more positive, so we lost electrons. That's oxidized. This one is difficult because we have a negative and it goes to a positive. So let's just look at these last two. How do we do these ones? Well, we want to figure out the actual oxidation number for each one of these elements. Why couldn't we do that in these first ones? Or why did we not have to? Well, if it's just a singular element, we know based on the charge the oxidation number. So if it's neutral, it's a oxidation number of 0, and this would be a +2 oxidation number. And so if we go 0 to +2, the oxidation number increased, and that would be reduction. So let's look at our bottom two. Oxygen always has oxidation number -2. They have to add up to the total charge in the compound. So -2 times 3 is -6, so this must be a +5. And then we have -2 here, and this is +2. So we go from +5 to +2. If I write that with just the nitrogen, it would look like this: nitrogen, and then nitrogen +2. If you had to balance a half reaction here, we need 3 electrons on this side, so that the total charge on the left side is +2 and the total charge on the right side is +2. So this is gaining electrons. Gaining electrons, if we go back to our oil rig, gaining electrons is reduced. That's what we want in this problem. And so that's why D is the correct answer. Let's evaluate E just for practice. Oxygen's a -2. -2 times 3 is -6, and we need a -2 charge overall. So the sulfur would be +4 here. And then -2 here, -2 times 4 is -8. And we have to add up to -2 charge for the compound. And so if we get -8 from my oxygens, the sulfur here has to be +6. So +4 to +6, it increases just like these ones, and this would be oxidized. For the dissolution, representing the equation above, which of the following pairs includes Bronsted-Lowry bases? Well, we want to evaluate what happens to the proton up here. So if our HCl starts out on the left side and turns into Cl on the right side, what did HCl do? Well, it lost this proton. It donated the proton right here. A proton donor, the Bronsted-Lowry definition of an acid is a proton donor, so this is an acid. Well, the H2O accepted the proton. That's how it turns from H2O to H3O+, so that makes this a base. Going backwards from the reaction, if we start on the product side and go to the left, chlorine would have to gain a proton to turn back into HCl. And so this is the proton donor, and this is the proton receiver. So this is the base, and this is the acid. So what are we looking for? H2O and Cl minus. Where do we find that? Right here, D, H2O and Cl minus. Here's a titration experiment. It asks you about oxidation numbers, and it doesn't tell you which element it is. It just says identify which element is being oxidized. Oxidation involves loss of electrons. What is the element's change in oxidation number? So we'd have to go through this problem again using our oxidation number rules. Your oxidation number rules for H2O2, this is a peroxide. Hydrogen is a +1, and oxygen is a -1. In MnO4, we have a -2 for oxygen. We have a +1 for hydrogen here. Manganese would have to be, if they add up to a total charge of -1, this would have to be a +7. If we go to this side, we have a +2, a +1, -2, and a 0. So what do we have going on here? Well, we have some of our oxygen going from -2 to -2, so it did not change. But some of our oxygen goes from -1 to 0. So what's our correct answer here? What we want to recognize first, manganese. What did it do? Gain electrons or lose? This gained, so this was, it gained 5 electrons. This was reduced. We want what's oxidized, so the oxygen is what gets oxidized. And we could connect these two, or we could connect these two and go from a -2 to 0 or -1 to 0. You wouldn't be able to differentiate between those two. So we wouldn't be able to decide if it's this oxygen or this oxygen that's getting oxidized. It could be either or. And so what's our correct answer? -1 to 0 is a possibility. 0 to -2, that doesn't even work with oxidation. This would be reduced. So this is our correct answer. That's it for that particular review. You guys did fairly well on that. Good job.